Welcome. This is the part 2 video of the mathematical induction. So how should I do this then? It is using the concept of divisibility test. So the first question, part A, it is divisible by n. So let us assume that n equals to 1. So it becomes 8 power 1 minus 1, which is 7, which can be written as 7 times 1. Therefore, it is true for n equals to 1. Let us assume that it is true for n equals to k. So 8 power k minus 1 is divisible by 7. 7 means I'll write it as 7p. Over here, make 8 power k as a subject. So it becomes 7p plus 1. Now I have to prove that it is true for n equals to k plus 1. 8 power k plus 1 minus 1 should be proved it as 7 times something. I should be able to prove it is 7 times something. So 8 power k plus 1, how can I write as 8 power k plus 1 as 8 power k times 8 minus 1. Just now we know that 8 power k is nothing but what? 7p plus 1 times 8 minus 1, which is 7p times 8 plus 8 minus 1, which is nothing but what? 7p times 8 plus 7. Clearly we can see that we can take 7 common, so it becomes 8p plus 1. So therefore it is divisible by 7. So therefore by principle of mathematical induction, it is true for all values of n, for all positive integers of n. That is the first one. Now coming to the second question, we have to prove that it is true 3 power 2n minus 1. Second question is 3 power 2n minus 1 is divisible by how much? Is divisible by 8. So let n equals to 1. So it becomes 3 power 2 minus 1, which is 8, which is 8 times 1. So therefore it is true for n equals to 1. Now we shall assume that it is true for n equals to 2. Or n equals to 2, instead of n equals to 2, we can take n equals to k. Let us assume 3 power 2k minus 1 equals to 8 times p. Make 3 power 2k as a subject. 3 power 2k equals to 8p plus 1. Now we have to prove that it is true for n equals to k plus 1. 2k plus 1 minus 1 should be equals to, my final answer should be, it is divisible by 8. It should be 8 times of something. So what am I going to do? 3 power 2k plus 2 minus 1. But I want only 3 power 2k, right? So 3 power 2k times 3 power 2 minus 1, which is 3 power 2k is just now we have assumed as 8p plus 1 times 9 minus 1. So 9 times 8p plus 9 minus 1. So which is nothing but what? 9 times 8p plus 8. Take 8 common, 9p plus 1. So therefore it is divisible by 8. By principle of mathematical induction, it is true for all positive integers of n. Don't forget to write the conclusion. Part C now. Part C, 5 power n plus 9 power n plus 2 is divisible by 4. Let n equals to 1, 5 power 1 plus 9 power 1 plus 2, which is equals to 16. So it is 4 times 4, which is true for n equals to 1. Let us assume that it is true for n equals to k. 5 power k plus 9 power k plus 2 equals to 4p. Now over here, which one has to be made as a subject? Whichever one you want, you can make it as a subject. I make the most difficult one, maybe 9 power k as subject. So it becomes 4p minus 5 power k minus 2. You can take 5 power k as also as subject, does not matters. Now we have to prove that it is true for k plus 1. 5 power k plus 1, 9 power k plus 1 plus 2 should be equals to 4 times of something. So how should I get that one? 5 power k plus 1 can be written as 5 power k times 5. 9 power k plus 1 can be written as 9 power k times 9 plus 2. Now we can plug in 9 power k. So this 5 power k times 5 will remain as it is. 9 power k becomes 4p minus 5 power k minus 2 times 9 plus 2. So what does that becomes now? 5 power k times 5 plus 9 times 4p minus 9 times 5 power k minus 9 times 2 plus 8. 5 power k times 5 and minus 9 power Minus 9 times 5 power k will become negative 4 times 5 power k plus 9 times 4p. Then minus 9 times 2. This is plus 2. Minus 9 times 2. Minus 9 times 2 is nothing but minus 18. Minus 18 plus 2 is nothing but what? Minus 16. Can I take 4 common from everywhere? Yes, when I take 4 common, it becomes negative 5 power k plus 9p minus 4. So therefore, it is divisible by 4. So ultimately, you should be able to take 4 common. So the main intention is you can make any of the term as subject and can replace it out to further simplify. So by principle of mathematical induction, it is true for all positive integers of n. That is C. Coming to part D. 2 power 4n minus 1 is divisible by 15. So n equals to 1 means 2 power 4 minus 1, which is 15, equals to 15 times 1. Therefore, it is true for n equals to 1. Assumption 2 power 4k minus 1 equals to 15p. Make 2 power 4k as a subject. It becomes 15p plus 1. Now I have to prove that it is true for n equals to k plus 1. 2 power 4 times k plus 1 minus 1. So it should be proved as 15 times something. So how do I do that one? 2 power 4k plus 4 minus 1, which is 2 power 4k times 2 power 4 minus 1, which is 16 times 2 power 4k minus 1. What is 2 power 4k? 15p plus 1. So 16 times 15p plus 1 minus 1. So it becomes 16 times 15p minus 16 plus 16 minus 1. So it becomes 16 times 15p plus 15. Take 15 common, 16p plus 1. Therefore, it is divisible by 15. By principle of mathematical induction, it is true. Next, question number E. 3 power 2n minus 1 plus 1 is divisible by 4. So plug in 1, 3 power 2 minus 1 plus 1, which is nothing but what? 3 power 1 plus 1, which is 4. Yes, it is divisible by 4. Let us assume that it is divisible n equals to k. So it equals to 4p. Make 3 power 2k minus 1 as subject. It becomes 4p minus 1. Now we have to prove that it is true for n equals to k plus 1. 3 power 2 times k plus 1 minus 1 plus 1 should be equals to 4 times something. So it becomes 3 power 2k plus 2 minus 1 plus 1. I will not simplify it out over there. Rather than I'll write 3 power 2k minus 1 plus 2. Why do I write that like that? 3 power 2k minus 1 times 3 square plus 1. So what does that becomes? 3 power 2k minus 1 can be plugged in, which is 4p minus 1. 4p minus 1 times 9 plus 1. So which becomes 36p minus 9 plus 1, which becomes 36p minus 8. Can I take 4 common? 9p minus 2. So therefore it is divisible by 4. So therefore by principle of mathematical induction, it is true for positive integers of n. Next one, f n cube plus 6n square plus 3n plus 8n is divisible by 3. Plug in n equals to 1, 1 plus 6 plus 8, which is 15, which is 3 times 5. Therefore, it is divisible by n equals to 1. It is divisible by 3 when n equals to 1. Now, let us assume that it is divisible by 3 when n equals to k. K cube plus 6k square plus 8k equals to 3p. So make whichever as a subject. So k cube is a difficult one. I take k cube equals to 3p minus 6k square minus 8k. Now I have to prove that it is true for n equals to k plus 1. So k plus 1 whole cube plus 6 times k plus 1 whole square plus 8 times k plus 1. This should be coming something as 3 times of something. K plus 1 whole cube is k cube plus 3k square plus 3k plus 1. 6k plus 1 whole square is 6k square plus 12k, I'm writing it out directly, plus 6 plus 8k plus 8. Now we know that k cube is 3p square minus 6, 3p minus 6k square minus 8k. 3p minus 6k square minus 8k, and remaining all terms will remain as it is. So what is that? 3k square plus 6k square is 9k square. 3k plus 12k is 15k. 15k plus 8k is 23k. And 1 plus 6 is 7. 7 plus 8 is 15. So what does that becomes now? 3p. 9k square plus 6k square is 3k square. And 23k plus minus 8k is 15k plus 15. Can I take 3 common from everything? P square plus p plus k square plus 5k plus 5. Therefore, it is divisible by it is divisible by 3 for n equals to k plus 1. So by principle of mathematical induction, it is true. Next one, n cube plus 5n is divisible by 6. So plug in n equals to 1. 1 cube plus 5 times 1, which is 6, which is equals to 6 times 1, true. Assume that it is true for n equals to k equals to 6p. Make k cube as a subject. It becomes 6p minus 5k. Now we have to prove that it is true for n equals to k plus 1. K plus 1 whole cube plus 5 times of k plus 1. So k cube plus 3k square plus 3k plus 1 plus 5k plus 5. Now k cube can be replaced with 6p minus 5k. 6p minus 5k plus 3k square plus 8k plus 6. So it becomes 6p plus 3k square plus 3k plus 6. Take 3 common, 2p plus k square plus k plus 2. Therefore, it is true for n equals to k plus 1. So by principle of mathematical induction, it is true for positive integers of n. Then in the first question, the last one, h, 2 power n times 3 power 2n minus 1 is divisible by 17. N equals to 1. 2 power 1, 3 square minus 1, which is 18 minus 1, which is 17, which is 17 times 1. It is true for n equals to 1. Let us assume that it is true for n equals to k, means 17p. Make that as a subject. 2 power k times 3 power 2k equals to 17p plus 1. Now I have to prove that it is true for n equals to k plus 1. 2k plus 1, 3 power 2 times k plus 1 minus 1. It should be equal to 17 times something. So 2 power k times 2 power 1 times 3 power 2k times 3 power 2 minus 1. So it becomes 2 power k times 3 power 2k times 9 times 2 is 18 minus 1. 2 power k times 3 power 2k is 17p plus 1. So 18 times 17p plus 1 minus 1, which is 18 times 17p plus 18 minus 1, which is 18 times 17p plus 17. So take 17 common, 18p plus 1. So therefore it is true for n equals to k plus 1. So by principle of mathematical induction, it is true. Coming to question number 2, show that f of k plus 1 equals to 6 times f of k plus 13 times 13 power k. So first of all, I'll try f of k plus 1. What is f of k plus 1? 13 to the power of k plus 1 minus 6 to the power of k plus 1. So it becomes 13 times 13 power k minus 6 times 6 power k. Now what should I be able to get it out? I should get 6 times f of k. So how should I do this one now? Now what can I do this? This 13 can be written as 7 plus 6 times 13 power k minus 6 times 6 power k. So now expand this one. 7 times 13 power k plus 6 times 13 power k minus 6 times 6 power k. Now in these both, 6 can be taken common. 7 times 13 power k plus 6 common means 13 power k minus 6 power k. What is 13 power k minus 6 power k is nothing but what? F of k. So 7 times 13 power k plus 6 times f of k. That's going to be the first part answer. Hence or otherwise, prove by induction that it is for all positive integers of n, it is divisible by 7. So we have to prove that it is divisible by 7. 13 power k minus 6 power k. 13 power n minus 6 power n is divisible by 7. Let n equals to 1. 13 minus 16, 6 is 7, which is 7 times 1. It is divisible by 7, 1 or 7. Now let us assume that it is divisible by 7 for k equals to 7p. Make 13 power k as a subject, 7p plus 6 power k. Now we have to prove that it is true for n equals to k plus 1. 6 power k plus 1 equals to 13 power k times 13 minus 6 power k times 6. Now I make 13 power k as a subject, so I can plug in over there. It becomes 7p plus 6 power k times 13 minus 6 power k times 6. So it becomes 13 times 7p plus 13 times 6 power k minus 6 times 6 power k. So 13 times 7p plus 7 times 6 power k. I can take 7 common, 13p plus 6 power k. So therefore it is divisible by 7. So by principle of mathematical induction, it is true for all positive integers of n. Question number 3. Prove that again g power k plus 1 equals to something. So g power k plus 1 means 5 power 2 times of k plus 1 minus 6 times of k plus 1 plus 8. So what does it becomes? 5 power 2k plus 2 minus 6k minus 6 plus 8. So it becomes 5 power 2 times 5 power 2k minus 6k plus 2. So it becomes 25 times 5 power 2k minus 6k plus 2. Now I have to prove it out. It is should be equals to 25 times gk plus 9 times 16k minus 22. So what I can do? I can do the bottom up approach. So 25 times gk. What is gk? 5 power 2k minus 6k plus 8. Then plus 9 times of 16k minus 22. Plus 9 times of 16k minus 22. So what does that becomes? 25 times 5 power 2k. Previous step would have been minus 150k plus 200 plus 144k minus 22 times 9 is 208. So I should be able to do that in a bottom up approach is 188, not 208, 198. Now from there, what should I be able to get that one? 25 times 5 power 2k. This becomes negative 6k and this becomes positive 2. So see, these two steps are the same. So we need to able to get it out in the bottom up approach, and we can prove that both are same. That's going to be the way. How should I prove it? Hence or otherwise, prove that it is divisible by 9. So what was the question? 5 power 2n 5 power 2n minus 6n plus n is 8 is divisible by 9. Let n equals to 1. 5 power 2 minus 6 plus 8. 25 minus 6 plus 8, which is 25 minus 6 is 19. 19 plus 8 is 27, which is 9 times 3. It is divisible by 9. Let us assume that it is divisible by 9 when n equals to k equals to 9p. Make 5 power k as a subject, 5 power 2k as a subject, it becomes 9p plus 6k minus 8. Now we have to prove that it is true for n equals to k plus 1. K plus 1 minus 6 times of k plus 1 plus 8. So what does that becomes? 5 power 2k plus 2 minus 6k minus 6 plus 8. 5 power 2k can be plugged in as 9p plus 6k minus 8 times 5 power 2, which is 25, minus 6k, 8 minus 6. 8 minus 6 is 2. So it becomes 25 times 9p plus 25 times 6k minus 25 times 8 minus 6k plus 2. And I should see that it is divisible by 9. 25 times 9p, this becomes 24 times 6k. 24 times 6k minus 198. Can I take 9 common? 25p, then 24 times 6 divided by 9. So it becomes 18. It becomes 16. 16k minus, what is this? 198 divided by 9 is 22. So therefore it is divisible by 9. Therefore it is true for positive integers of n. Question number 4. Prove that 8 power n minus 3 power n is divisible by 5. So let n equals to 1. 8 minus 3, 5, which is 5 times 1. It is divisible by 5. So let us assume that it is divisible by 5 for n equals to k. So make 8 power k as a subject. 8 power k equals to 5 plus 3 power k. Now we have to prove that it is true for n equals to k plus 1. 8 power k plus 1 minus 3 power k plus 1. It is 8 power k times 8 minus 3 power k times 3. What is 8 power k? Is 5 plus 3 power k times 8 minus 3 power k times 3. So 5 times 8 plus 8 times 3 power k minus 3 times 3 power k. So it becomes 5 times 8 plus 5 times 3 power k. Take 5 common, 8 plus 3 power k. So therefore it is divisible by 5. Question number 5. This is divisible by 8. So plug in n equals to 1. 3 power 4 plus 8 times 1 minus 9. 3 power 4 is 81. 81 plus 8 minus 9, which is 80, which is 8 times 10, divisible by 8. Let us assume that it is divisible by 8 when n equals to k. Plus 8k minus 9 equals to 8p, which is the most difficult one, 3 power 2k plus 2. Make that as a subject, 8p minus 8k plus 9. We have to prove that it is true for n equals to k plus 1. 3 power 2 times k plus 1 plus 2 plus 8 times k plus 1 minus 9. So it becomes 3 power 2k plus 2 plus 2 plus 8k plus 8 minus 9. So it becomes 3 power 2k plus 2 times 3 power 2 plus 8k minus 1. 3 power 2k plus 2 is 8p minus 8k plus 9. 8p minus 8k plus 9 times 9 plus 8k minus 1. So it becomes 9 times 8p minus 9 times 8k plus 81 plus 8k minus 1. So it becomes 9 times 8p minus 8 times 8k. These two becomes minus 8 times 8k. These two becomes 80. Can I take 8 common? So 9p minus 8k plus 10. So it is divisible by 8. So by principle of mathematical induction, it is true. So one more question. This is divisible by 5. So let n equals to 1, 2 power 6 plus 3 power 0. 2 power 6 is 64 plus 1, 65, which is 5 times 13 divisible by 5. Let us assume that it is true for n equals to k. So 3 power 2k minus 2 equals to 5p. So which is the difficult one? 3 power 2k minus 2 equals to 5p minus 2 power 6k. We can make anything as a subject. So it is true for n equals to k plus 1 has to be proved. Plus 3 power 2 times of k plus 1 minus 2. So 2 power 6k times 2 power 6 plus 3 power 2k minus 2 times 3 power 2. So when I do that, it should be in that way. So 3 power 2 per 3 power 2k minus 2 can be plugged in over here as a substitution part. So 2 power 6 is nothing but what, 64 times 2 power 6k plus 9 times, this is 5p minus 2 power 6k. So it becomes 64 times 2 power 6k plus 9 times 5p minus 9 times 2 power 6k. So 64 minus 9 is that what? 55. 55 times 2 power 6k plus 9 times 5p. Take 5 common. 11 times 2 power 6k plus 9p. So it is divisible by 5. Therefore, by principle of mathematical induction, it is true for all values of positive values of n. So see you in the next video. Bye.